No, you'll have to come and see for yourself. We're living in the 21st century, you know. Surely you should know about GPS, MP3, iPods, notepads. Well, all these electronic gadgets use energy, and that comes from electricity. I don't know which gadgets use less power than others. Yeah. Oh, hello viewers. Welcome to our first lesson in our grade 10 physical science series. This series has 5 lessons on grade 10 physical science syllabus topics. As you can see them on the screen, it includes understanding current, understanding potential difference and resistance, electromagnetism, metal reactivity, and bonding. The topic of today's lesson is understanding current. After watching this lesson, learners should be able to explain charge by the imbalance of electrons and protons known as static electricity. Calculate current as a number of charges per time. I equals Q divided by T. Explain that electrical current is determined by the flow of charges and is measured in amperes. Symbol A, using an ammeter. Distinguish between series and parallel connections in a circuit. Distinguish between electron and conventional current. And distinguish between direct and indirect current.
Static electricity is created when there is friction between objects. The objects become positively and negatively charged, respectively, when they rub against each other. When the children rub their feet on the carpet, it creates static electricity. The moment when two children touch each other, electric charges flow between them to equalize the difference in charge. When we have a constant flow of charge through a conductor, it is known as current. The strength of the current can be calculated as the number of charges flowing through a point every second. Here's the formula. I equals Q divided by T. Now I stands for current and its unit is ampere. Q stands for the amount of charge and its unit is coulomb. T stands for time and its unit is seconds. Let's solve a problem using this formula. An amount of 400 coulomb of electricity passes through a certain point in an electrical circuit in 200 seconds. What is the current in the circuit? Let's apply our formula, which is I equals Q divided by T. We said that the value of Q is equal to 400 coulomb and that time is 200 seconds. When we substitute the values in the formulation, we have 400 coulomb divided by 200 seconds and we get a current strength of 2 ampere. For a current to flow through a conductor, it needs a complete path, like a closed circuit. We can build a simple circuit using insulated wires, an energy source, which we call cells, an open switch, but in this case we'll use a light bulb, and an ammeter. These things will be used to build a circuit and to measure the current flowing through the circuit. It is important that the ammeter must be connected in series in a circuit. The insulated wires. First, we need an energy source. Then the insulated wires. Another one. A question. Why is the bulb not glowing? Yes, because the circuit is open. A closed switch will complete the circuit and current will flow through it, making the light bulb glow. Let's see the amount of current running through the circuit from the ammeter. The reading is 0.2 ampere. We can use a diagram to illustrate the circuit that we have built, like this. A single line represents the conductor. The energy source is a cell, and this is the symbol for it. This is the symbol for the light bulb, and this is the symbol for an ammeter. The symbol for a switch symbol is either open or closed. Here is an example of a series circuit where components are in line with one another and there is just one path for the current to flow. The current is the same at all points in the circuit. This is an example of a parallel circuit where the current is divided when the alternative paths for the flow of electricity are provided. Here we find that the sum of the current in the branches of a parallel circuit equals the current entering the section. The theory of what happens inside the circuit is summarized by two concepts. The first is that with the conventional current direction, positive particles flow in the conductor from a positive to a negative terminal, as this diagram illustrates. In the second theory, negatively charged electrons move in the opposite direction to that of the conventional current. This is known as electron current. Please take a moment to see the difference between these two current flows.
Hi there again. So which energy sources do we use for our electronic devices? I know it's easy because I have to buy it. It's easily plugged into a power point or when it runs on a battery. When using a battery, for example this remote control, the current will flow in one direction only. This is known as direct current or DC. In contrast, mains electricity is alternating current or AC, where the current changes direction 50 times a second. Let's summarize what we have learned about electric current. Static electricity is created when electrical charge builds up on the surface of a material. Static means still, motionless, or not moving. It is called static because there is no circuit and no current is flowing. Electric current is the flow of charge and is measured in amperes using an ammeter which is connected in series in a circuit. Conventional current is positive charges moving around a circuit and the direction is from the positive terminal to the negative terminal of a cell. This is known as the conventional flow. In an electron current, electrons move in the opposite direction to the conventional current. In a direct current or DC, the electrons flow in one direction only. In an alternating current or AC, the direction of flow reverses regularly at the speed of 50 times in 1 second. Batteries produce direct current. Mains electricity, for example the Van Eck power station in Windhoek, produces alternating current. Now it's time for our SMS competition question. It works like this. You SMS the keyword current and then option A, B or C as the answer to the number 5003. Each SMS costs 3 Namibian dollars. Here's the question. The unit in which charge is measured. Is it option A, T, option B, Q, or option C, C? Thank you for watching. See you next time.